This video is on implicit differentiation, and this is designed to go along with the MasterMathMentor book, page 51. So I'm going to do some problems that are very similar to those problems, just so you see how things work. So number one, the problem I'm going to do is 3x squared, 3x squared minus 2y to the fourth equals negative 33. And that's at the point 4, negative 1. So implicit differentiation is different because, as you see, we have x's and y's all mixed in together. And for this particular problem, it would certainly be possible to solve for y. You'd get y equals something to the fourth root, or a fourth power of something. A fourth root of something. But it wouldn't really be worth your time because you might as well just do implicit differentiation, and it's faster and shorter. So we use this anytime we can't get y by itself easily, or if we don't want to get y by itself. So it works almost exactly like how normal differentiation works. So for example, 3x squared, the derivative of that would be 6x. And then negative 2y fourths is to the fourth power is almost exactly like how we normally take the derivative. It would be negative 8y cubed. But there's one difference. If you think about this as the chain rule, we have negative 2 times something to the fourth power. So the chain rule says bring that 4 out and reduce it by 1. But then remember, we have to take the derivative of what's in the inside, or what's one layer down. In this case, that's y. So the derivative of y would just be dy dx. So the derivative of y is literally the derivative of y. So that's one important thing to remember when you're doing implicit differentiation, is anytime you do something where you end up taking the derivative of y, you need to stick dy dx onto the end of it. Okay? The other sort of different thing is that now we have equal signs, whereas we really didn't deal with those before. So you have to take the derivative of the other side also. In this case, the derivative of negative 33 is 0. Okay? So we're trying to solve for dy dx at a specific point. In this case, it's 4, negative 1. So they're asking us what's the slope of the curve at that point. So I'm going to get dy dx by itself. I'm going to move that 6x over. So I have negative 8y cubed dy dx equals negative 6x. Okay, I'm going to divide both sides by negative 8y cubed. So we have dy dx equals, so it's negative 6x over negative 8y cubed. And you could reduce that, but I'm not going to because I know I'm just going to substitute points in anyway. So if I substitute those points in, I have 6 times 4. I got rid of the negatives because I know that they're gone. And then 8 times negative 1 cubed. So 6 times 4 would be 24. 8 times negative 1 cubed is going to be negative 8. And so our answer would be negative 3. So the slope at that point is negative 3. Okay, let's look at another example. This is similar to example 2 in your book. We have 3xy plus x equals negative 6. And we'll do this at the point 1, 1. So important note here, it's x times y, two variables being multiplied by each other. That means that we need to use the product rule. So I'm going to start by leaving 3x alone. Okay, so that stays alone, that stays tall. The derivative of y is 1, just like the derivative of x is 1. But then remember, anytime you take the derivative of y, you need to stick on a dy dx. Okay, so that's the first part. Plus, now I'm going to leave y alone. And then the derivative of 3x is 3. I don't have a dy dx here because I did not take the derivative of y for that part. Okay, so that's all that part. And then the derivative of x would be 1. And then the derivative of negative 6 is 0. So one thing you can do at this point is move everything over so that dy dx is by itself. But since I'm going to plug in points anyway, you have the other option of just plugging the points in and then solving for dy dx. So I'm going to show that method here. Either one works for these problems. So we have 3 times 1 dy dx plus 1 times 3 plus 1 equals 0. So it's 3 dy dx plus 4 equals 0. And then I'm going to subtract the 4 and divide by 3. So I end up with dy dx equals negative 4 over 3, and then that would be your answer. So again, just like the last one, we got our answer as dy dx equals something. It's just that we plugged in the points and then solved for dy dx. On the previous problem, we solved for dy dx and then we plugged in the points. It's up to you how you want to do that. Okay, a problem similar to number 3. We have x y squared plus x cubed y equals negative 3y. So now we have two things where we have to do the product rule. X times y squared, so the first thing is x and the second thing is y squared. And then x cubed y, the first thing is x cubed, the second thing is y. So I'm going to start with the xy squared. I'm going to leave the x alone and then take the derivative of y, which will be 2y dy dx, plus, now I'm going to take the derivative of x, which is 1, so I'm not going to write it, and then leave the y alone, y squared. There's no dy dx because I didn't take the derivative of y. So that's the first part. Now I'm looking at the x cubed plus y. Same deal. I'll leave x cubed alone, and then dy dx plus 3x squared y. Okay? And then the last thing is the other side of the equal sign. The derivative of negative 3y would be negative 3, but then you have to multiply by dy dx. Okay, so let's, just for practice, let's go ahead and solve for dy dx. The first thing I'm going to do is move all of the dy dx's to one side, and then everything else that's not related to the other side. So I have x 2y, I know that's in a funny order, but that's okay, dy dx plus x cubed dy dx, and then I'm going to move that negative 3, this one over here, I'm going to move that over, so it'd be plus 3 dy dx, okay, equals, now I move everything over, so we've got just the y squared actually, so it's just negative y squared. Okay, so that's the first step, is move all the dy dx's to one side and all the other random things to the other side. Your next step is to factor out a dy dx. So we have, I'm going to write this in the right order because it's making me mad. Can I scratch that out? No, let me erase that. Okay, so 2xy, that's much better, plus x cubed plus 3 equals negative y squared. And then your last step is divide both sides by dy, or by the stuff in the parentheses. So we have dy dx equals all this in the bottom, 2xy plus x cubed plus 3, and then it's negative y squared that was originally there in the numerator. So now I can plug in the values. So I have, oh, I didn't give this values. Let's make this 0, 3. Okay. So we're going to have negative 3 squared over 2 times 0 times 3 plus 0 cubed plus 3. So that's going to equal negative 9. That negative is not getting squared. It's on the outside. And then in the bottom, 2 times 0 times 3 is 0. 0 cubed is 0. And so all we have left is 3. So that simplifies to negative 3. Okay. So sometimes there's a little bit more that you have to do, and I know this looks really messy, but it's the same 3 steps in general. You move all the dy dx's to one side and all the non-dy dx's to the other side, factor out a dy dx, and then divide, and you have your answer. And even though it looks messy, you're basically just copying stuff over and over again, so you really don't have to put a lot of thought into how exactly you're doing that. Okay, example 4, let's do this. X plus square root of x squared y, and that equals 5x. And we're going to do this at the point 3, negative 1. Okay. So we'll take the derivative. Derivative of x is 1. Here we have chain rule and then product rule. So remember, this is going to be, I'll write it over down here, just so you see it, it's x squared y to the 1/2 power. So I'm going to say 1/2 x squared y to the negative 1/2. And now I need to do the derivative of the inside, which involves the product rule because it's x squared times y. So we have x squared, derivative of y would be dy dx, plus derivative of x squared is 2x, and then we leave the y alone. Okay, and then that's all going to equal 5. Now I can solve for the dy dx, but I think sometimes, and this is a perfect example, it's a little bit easier to just plug the numbers in first and then solve the dy dx, because then at least you have less going on. So I'm going to show that here. So we have 1 plus 1/2 x squared would be 9 times negative 1. I managed to give myself an imaginary number without realizing it. Let me make this a positive one just so that we don't do that to ourselves. Okay, so to the negative 1/2 power, and then this is going to be 1 squared dy dx plus 2 times 3 times 1. I'm sorry, x is 3, not 1. So that's x, so it should be 3. And then that is equal to 5. And hopefully I didn't copy anything else down wrong. Okay, so be careful. You cannot add these two because this second guy is being multiplied here. So don't just randomly combine stuff. So we have 1 plus 1/2, and then the 9 times 1 would be 9, and 9 to the negative 1/2 would be 1/3. So I have 1/3, because 9 to the 1/2 is 3, so 9 to the negative 1/2 must be 1/3. And then that's going to be times 9 dy dx plus 6 equals 5. Okay. I'm trying to save, oops, what did I do? Okay. I'm trying to save paper, or not paper, but ink or space here. So I'm going to go ahead and move this 1 over to the other side. It's not going to let me. Okay, so that crashed. So I redid it, and hopefully I have exactly the same thing as what it just stopped with. So 1 plus 1/2 times 1/3, and then times 9 dy dx plus 6, and then equals 5. I think I might have had a 5x, and I meant to have 5, but I don't remember now. Maybe I'm saying that wrong, but hopefully you're okay with this. So we have 1 plus 1/6, and then 9 dy dx plus 6 equals 5. And that's where I was, I was trying to subtract the 1 over to the other side when it froze. So I want to move that 1 over. So this becomes 4 because I'm subtracting. Okay, I'm going to multiply both sides by 6 to get rid of the 1/6 there. So we have 9 dy dx plus 6 equals 24. Okay, I'm going to subtract that 6. So it's 9 dy dx equals 18. And then the last step is to divide by 9. So dy dx equals 2, and that should be the answer, assuming I didn't make any silly mistakes. So you see that sometimes maybe it's a little bit easier to just plug the number in and then afterwards solve for dy dx, as long as you end up with dy dx. Either way works for these. Okay, so now we're at example 5. And example 5 actually has a mistake, I think. The 2 that you see at the end where it says plus 2, I think it should be equals 2, because you really can't do anything if you don't have equals something. How could you solve for dy dx? So it should be equals 2, and then you can get an answer for it. But the problem I'm going to do is this. So x plus 3y cubed plus 2x equals y. And I'm going to do this at the point -1, 3. Okay. So we see here this x plus 3y is going to involve the chain rule. So I'm going to have 3, keep everything inside the same, and then multiply by the derivative of the inside, which is going to be derivative of x is 1 derivative of 3y is 3 dy dx. Okay, and then plus that 2x right here is going to become 2, and then equals the derivative of y is dy dx. And I'm going to go ahead and solve for dy dx. So I need to distribute. You see that all of this is being multiplied by both of those things. So we have 3, I bet I'm going to run out of space, plus 3y squared times 1, so I'm not going to write that, plus, and then the 3 and the 3 here make 9, x plus 3y squared dy dx. Don't forget him. He came from right here. And then carry that 2 down, and the other dy dx. Okay? And then it's just the same thing I was saying earlier. Get all the dy dx's to one side, then factor the dy dx out, and then divide, and you're done. So I'm going to do this in a different color, hopefully make it slightly less confusing. So we have 9 times x plus 3y squared dy dx. I'm going to subtract that other dy dx. Okay. And then that's going to equal, I'm going to move this 2 over, so it becomes negative 2, and then I'm going to move that other term over. Oops. So minus 3, there we go, x plus 3y squared. Okay, so now we're going to factor out a dy dx. So dy dx, and then inside is first going to be this 9 times x plus 3y squared, and then minus the dy dx here has a coefficient of 1. It's just not written there. So we have that equals negative 2 minus 3x plus 3y. So again, like I said earlier, you're just copying a lot of stuff. You don't really have to think about the math of what you're doing. You just copy. Okay, our last step is that we're going to divide both sides so that we get dy dx by itself. So we have negative 2 minus 3 times x plus 3y squared all over 9 times x plus 3y squared minus 1. So that's a lot, but it's okay. We're almost done. We just want to remember that we have to plug in some points. So we're going to have negative 2 minus 3. X is negative 1. Y is 3, so I'm going to go ahead and multiply that and get 9. That's squared. Over 9 times, x again is negative 1, plus 9, same deal, squared minus 1. And then we just simplify that. So we're going to have negative 2, negative 1 plus 9 is going to be 8. 8 squared is 64. And then 64 times 3 is 192. I didn't make the numbers that big on purpose, I promise. And then in the bottom, we still have 64 in the parentheses part there. And 64 times 9 is 576 minus 1. So this is going to be negative 194 over 575. And that's your answer, even though it's kind of a strange fraction to have. Okay? Let's go to example 6. So I'm going to do 3x squared minus y cubed equals 3y. And the point I decided to use was 4, 2. And I'm going to start changing colors because that's a little bit more exciting. So we take the derivative. We have 6x for this one minus 3y squared dy dx equals 3 dy dx, and hopefully you're more comfortable with this now. I want the dy dx's by themselves, so I'm going to move them to the left. So 3y squared dy dx minus 3 dy dx equals negative 6x. Factor out a dy dx. Whoa, that's x. So we have negative 3y squared minus 3 equals negative 6x. And then we just divide. So, oh, I was supposed to change colors. I get carried away. So let's say we have dy, that's a slightly different color, equals negative 6x over negative 3y squared minus 3. I'm going to plug in the points that we have here, the 4, 2. So we have negative 6 times 4 over negative 3 times 2 squared is going to also be 4 minus 3, which is going to be negative 24 over negative 12 minus 3 is negative 15, which is going to simplify to positive 24 over 15. And then if you divide them both by 3, so 24 divided by 3 is 8, 15 divided by 3 is 5, so you get your answer of 8/5 for that one. Okay, here's something similar to example 7. Let's say that we have cosine of xy equals 5. Notice on this one that they don't give us a point, so we're just solving for dy dx. We're just going to get the equation, and then that's done. Okay, so we take the derivative first. This is going to involve our chain rule. So we have sine xy, and then we're going to do the derivative of the inside. So we have x dy dx plus y times 1, because the derivative of x is 1, equals 0. Okay, we need to get the dy dx's by themselves, so let's distribute out that sine of xy. So we have sine xy times x dy dx plus sine xy times y. Let me fix this plus here, that's pretty ugly. Plus, okay, and that equals 0. I'm going to move that second term over so that we get the dy dx part by itself. So sine xy times x dy dx equals negative sine xy y. Okay, now I just do the dividing part. So dy dx equals, top is going to be negative sine xy times y. The bottom is going to be sine of xy times x. And you see that the sine xy's are actually going to cancel out. So we can write this even simpler. I'm almost out of colors. We can say that dy dx equals negative y over x. And then since they didn't give us a point, we just stop. That's as far as we go. Okay, something similar to number 8 could be 3y squared minus 4x squared equals 15. And here we're solving for the second derivative, so there's a little bit of extra work that we have to do on this one. Let's go ahead and find dy dx first. So we have 6y squared dy dx minus 8x equals 0. So 6y squared dy dx equals positive 8x, which means that dy dx equals 8x over 6y squared. So if we simplify that just a little bit, we get dy dx equals, I'm going to divide them both by 2, so we have 4x over 3y squared. So I'm going to leave that there for just a second. And now I'm going to do the derivative of what I see there. And you see that I'm going to have to use the quotient rule. So d squared y dx squared, so that's just taking the derivative of dy dx on the left side is just going to be the second derivative. And then we have low, d high is 4, minus high, d low will be 6y dy dx, all over low, which will be 9y to the 4th. So here's just the extra little trick that we have in here. You see that on the right-hand side we have a dy dx. Well, we know what dy dx is in terms of x. It's this 4x over 3y squared. So I'm going to rewrite it, and I'm going to replace it with that. So we have d squared y over dx squared equals 3y squared times 4. Let me just write 12. So 12y squared minus, that's going to be 24xy, and then dy dx, like I said, is 4x over 3y squared, and that's all over 9y to the 4th, like it was before. So we can simplify this just a teeny tiny bit more, even though I'm like totally running out of space here. So let's say equals 12y squared. Okay, the 24 and the 3 are going to cancel, so that's 8, but then times the 4, so let me actually write 32, so I don't have to take up another line. So let me say what I did just in case you got lost there. So 24 divided by 3 is 8, times 4 is 32, because remember this is basically 24 over 1 that you're multiplying. Okay. Then you have the two x's that are going to be in the numerator, so that's x squared, and then this y cancels out with one of those, so this is over 1y, and then that's all over 9y squared, I'm sorry, 4th. You could cancel it out more. I'm trying to think of how to do this since I don't have space. I wonder if I could write up here if that would be okay. I just want to make sure that you see all of the simplification that you could do. So let's say that we use this color, and I want to combine the things in the numerator. So we're going to have 12y cubed over y minus 32x squared over y. And then that whole thing is over 9y to the 4th. So in the numerator, we have 12y cubed minus 32x squared, the whole thing's over y, all over 9y to the 4th. And so finally, I can simplify down to, this answer, which I'm going to write in a different color because that blue is hard to see. We have 12y cubed minus 32x squared over 9y to the 5th power, because that y goes down in the denominator. So that would be my second derivative of y. Focus and make sure that you can get at least to this step here, because that means that you understand the implicit differentiation. From that point forward, it's all just algebra type stuff. Okay, number 10. This apparently already has something written on it. What do I do? I don't understand what I did. There we go. Okay, so did I say number 10? No, number 8. No, number 9. Number 9. Okay. So number 9, I have this as my similar example. Oops. So cube root, that's cube root of y plus x squared minus 5 equals 3y. And they want the equation at the point 3, 1. So in order to get the equation, we're going to use our handy dandy formula here. Y equals m times x minus x1 plus y1. I had no idea I could write so small on here. And so we need our m is the thing we're missing, because we have x1 and we have y1. So I'm going to take the derivative of this guy. He comes out to negative 1/3 y to the negative 2/3 plus oops, I'm sorry, dy dx, because we took the derivative of y. Oops. So dy dx plus 2x, the minus 5 is gone, and then equals 3 dy dx, okay? And we're ultimately trying to solve for dy dx. I'm going to just cheat a little bit and plug in the points here. I think that would be faster for this one. So we have negative 1/3, y is just 1 to the negative 2/3, dy dx plus 2 times 3 equals 3 dy dx. So this 1 to the negative 2/3, 1 to the any power is going to be 1. So we have negative 1/3 dy dx, x, plus 6 equals 3 dy dx. Okay, so that's going to be negative 1/3 dy dx minus 3 dy dx equals negative 6, which then in turn gives us dy dx. Factor out the dy dx, we have negative 1/3 minus 3 is negative 6. So negative 1/3 minus 3, or minus 9/3, is going to give us negative 10/3. So we have dy dx times negative 10/3 equals negative 6. And so finally, we have our answer for the dy dx with the actual numbers plugged in. So we have dy dx equals negative 6 times negative 3/10, which is, this cancels out and this cancels out. So we have 9/5 is our slope. But remember, we're trying to write the equation, so we need to go back up to that guy. And we're going to have y equals 9/5, x minus x1 is 3, plus y1 is 1. And that's our answer. Okay, last one, similar to example number 10. And I have 15x squared plus 32y squared plus 30x minus 15y plus 600, this is long, equals 0. Okay, and they want to know where is the slope horizontal, or the tangent line, where is it horizontal and where is the tangent line vertical. So before we can do anything, we need to actually figure out what dy dx is, of course. So let's take the derivative. We have 30x squared, or I'm sorry, x plus 64y dy dx plus 30 minus 15 dy dx, and then the 600 goes to 0, and the 0 is already 0, so it's just equals 0. Solving for dy dx, I'm going to move stuff around, so we have 64y dy dx minus 15 dy dx equals negative 30 minus 30x. Okay, go ahead and factor that guy out. So we have dy dx times 64y minus 15 equals negative 30 minus 30x. And then, of course, we have to divide. So we get dy dx equals negative 30 minus 30x over 64y minus 15. Okay, so now that we have that, if we want to know where the slope is, or where the tangent line is going to be horizontal, that's going to happen when the derivative equals 0. So I just need to look at the numerator. If I can make the numerator equal to 0, then I have that. So it's going to be negative 30 minus 30x equals 0. So this is for the horizontal. So negative 30 equals positive 30x. So negative 1 equals x. That's going to be at that point there. And then for the other part, well, I'll keep the same color. If we want the tangent line to be vertical, then it's going to be undefined. The slope will be undefined. So this bottom part here will be equal to 0. So 64y minus 15 equals 0. So 64y equals positive 15, and y equals 15 over 64. So you should go back and plug in the points so that you can get like an actual ordered pair, because it's asking for at what points. But A, I don't have enough space, and B, this video is already really long, so I'm just going to stop there, and you can kind of work on that. That's just going to be algebra type stuff. Okay, so hopefully that was helpful, and good luck with your homework.